Prepare to have your mind stretched. The heart of Jupiter is so unusual, so enigmatic, that even our best scientific minds are left scratching their heads. Picture this. At the center of the solar system's largest planet lies a core so incredibly dense and scorching hot, it pushes the boundaries of what we can reasonably understand. For decades, astronomers believed they had a handle on how Jupiter's bizarre interior came to be. One prominent explanation, the so-called giant impact theory, suggested that long ago, a massive protoplanet collided with Jupiter during its tumultuous formation. The aftermath of that cosmic smash-up, according to this view, left half of Jupiter's core, made from the battered remains of that ancient planet. This helped explain why the planet's core appears so fuzzy or diffuse, a finding that has both fascinated and perplexed researchers ever since. But here's where the story takes a dramatic turn. A group of international scientists, in a recent landmark study published in the monthly notices of the Royal Astronomical Society, have thrown a wrench into this long-standing theory. Their research, motivated by strange observations made by NASA's Juno spacecraft, challenges everything we thought we knew about the origins of Jupiter's mysterious core. Juno, tasked with peering deep into Jupiter's swirling atmosphere, discovered something odd. Layers of hydrogen and helium gradually blend together in the planet's core, rather than existing in neat, separate layers. Scientists have argued about this peculiar structure for years. To crack the case, the research team used a powerful supercomputer to simulate what would actually happen during a planet-sized impact. And this is the part most people miss. The results didn't match expectations at all. No matter how extreme the simulated collisions, the aftermath didn't produce that gradual mixing seen in Jupiter's core today. Instead, the materials would settle into sharp, distinct layers, as if nature's stubborn. But the controversy doesn't end there. In a twist, the team points out that Saturn, too, the runner-up in our solar system size contest, has a similarly diffuse core. Could this mean that all gas giants, not just in our own solar system, but perhaps across the galaxy, share this gradual forming, complex inner structure? If so, it might mean that truly cataclysmic collisions aren't as crucial to planet building as once thought. The fact that Saturn also exhibits a diluted core supports the argument for a slow, drawn-out process, rather than rare, high-impact events dictating their formation, adds co-author Luis Teodoro from the University of Oslo. Let's not forget the biggest question. Can we really write off massive impacts as formative events in planet-making, or are we overlooking a piece of the cosmic puzzle? As SETI Institute scientist Jacob Kigareus remarks, giant impacts have definitely shaped many worlds, but there's clearly more to the story. So, what's your take? Do you agree with the new view that Jupiter is the product of gradual growth? Or do you still think giant impacts could play a hidden role? Could there be another explanation scientists haven't even thought of yet? Share your thoughts. Do you find yourself siding with the controversial new findings? Or do you think the traditionalists have a point? Let the debate begin.